All right, guys, we're going to go ahead and get started. Welcome to today's lesson. We're going to start off section 3 here today and start off with the question, has Earth's climate changed in the past? You say, yeah, Miss Woods, we've seen Ice Age. Like, okay, good point. Although I would like to point out that Ice Age is not a scientific movie, just so you know, if you weren't aware already. Anyways, moving forward, we're going to go ahead and start off section 3, notes, changes in climate. I do want to say, guys, I apologize for any background noise. If you hear any traffic going by, I'm sorry. It's been a little noisy in this last little bit. So, but anyways, section 3, climate change. You're looking at a picture depicting spreading of glaciers across North America because, of course, yes, we have seen periods of heating and cooling in Earth's history. Heating-wise, during the Eocene period of Earth's history, we saw changes in tropical zones. Right now, we know that they are from 0 to 30 degrees, and from 30 to 60 degrees above the equator, we have temperate zones. Well, during the Eocene period, those tropical zones actually extended well into our region and into the United States and up into the temperate zones, so, or what we now call the temperate zones. Matter of fact, geologists say that the southern portion of the U.S. was actually would have been considered tropical. So you wouldn't need to go down to the Bahamas to see the tropics. You could actually just go to Kentucky. So interesting there. Now, currently, the period we are in is a second Cenozoic period. This is actually the ending of a recent ice age. Now, ice ages can last a couple million, even tens of millions of years. We have 5 ice ages in Earth's history that we know of, that we have labeled. They are a couple hundred million years apart in time. So right now we are currently ending our most recent one. Okay, so there are, but just because it's ice ages, sorry, that's what I was going to say. Just because it's ice ages doesn't mean that it's completely cold. Within each ice age, you do have some heating and cooling happening. Right now, in this Cenozoic, we have seen 7 glaciation events in our history. Now, glaciers, we know, are basically ice rivers, right? Or large masses of ice moving across the Earth. And we have seen evidence of that in Ohio, of course. So you see here, looking at Ohio, the western, especially the northwestern portion of Ohio, is known to be very flat. Now you can see some ridges and stuff. Matter of fact, in my area, you can see some ridges up here of motion. Those are actually what we call glacial deposits. Those are rocks and gravel beds that glaciers have left behind, and as they moved in and retreated, and they flattened all this out and they push all that stuff forward. As a matter of fact, we know that the foothills of the Appalachians were actually sort of eroded, were eroded by those glaciers. So it's not as hilly in our area. I know it seems like it could be hilly, but if you were to continue further south and go into West Virginia and Kentucky, you would know what hilly means, right? A lot of twists and turns there. So those are what were created by those glaciers. Now, those events, the periods of heating and cooling that we have seen, are attributed to small variations in our orbit, in Earth's orbit. Those changes, basically, the same reason we have seasons, but we're talking about bigger, longer term patterns. The orbit's changing, it's changing the amount of direct sunlight. So we have, think about it like summers that are lasting millions of years and winters that are lasting millions of years back and forth. Okay, so that is Earth's climate history. How do we know this? Well, we use different evidence from geology to help us out. First one, coral fossils. Okay, we've talked about these in the past by looking at the stripes created by coral fossils, just like tree rings, but these are rocks. So we've had these records for millennia. They've been around for millions of years, longer, so much longer than a tree ring. But we can look at those and see how the fossils were living, what was happening at that time, what kind of deposits there were there. So the other one would be glacial grooves and deposits. We've already talked about glacial grooves. Oops. Okay. We do that one. That's sedimentary rock. Of course, by looking at the rock record, what's being buried, what's being laid down. Are there rocks from another region that have ended up in this region? What would have brought them down? Those would be glaciers, those would be floods, that sort of thing. So sedimentary rock, here are your glacial grooves right here. So the scraping of rock, the erosion of rock as glaciers come down. So we see these, our best example is the glacial grooves in Kelly's Island. We've already talked about those. Okay. And then also, the other thing that we've done before are those ice cores. So looking at the history. So again, we've already talked about this, how we can learn about the climate's heating and cooling by looking at the organisms, the fossils, the sediments trapped in that ice as it forms. So those are some great examples of how we know about Earth's history. Now, so that's the past climate. What's happening today? Okay, well, there is currently some climate change happening. Okay, Earth's average temperature has increased during this past century. During the 20th century. This increase in temperature is known as global warming. Okay, so the increase in general of the temperature. Just a couple of clarifications on that. Temperatures are not rising at a constant rate. It's a general trend. So there have been some periods of heating and cooling. So this graph from our book shows what I mean by that. So you can see periods of cold, increased periods of warmth, but that curve in general is going up, and it's just keeping better, or just keeps getting hotter. So an example of periods of heating and cooling, first of all, the year without a summer, right? Those volcanic events we know can have some changes. We know that solar activity can cause changes. El Niños can cause some differences happening. So we're looking at what's happening in general on these trends. Okay. Now, some areas of Earth are seeing more changes in this than other areas. You can see a picture here. This is a picture of the square in Venice, which I can't remember the name of it, but I have been there. I was lucky enough to be there. But you can see that it's flooded at this point. Now, Venice, if you don't know, is a city built on an island, and that actually they built more island by putting in trash and wood and all this stuff there. So it's, when we say sea level, it's right at sea level. Do they experience floods? Yeah. But they've been experiencing more floods and more severe floods in the past several decades than they've seen before. And this is a city that's been around since, the 13th, 14th century. So they're seeing a lot of changes there. We are not only seeing changes in temperature, but we're also seeing changes in precipitation pattern. Some areas getting more rain than others. Other areas seeing drought more often than they have in the past. We've seen increased frequency of fires. You're going to read an article about what's happening in Australia. How do we see forest fires? Yes. Have we seen increases in them? Yes. Okay. Also increases in extreme weather. So we're going to talk all about these as we go through this section. Okay. The next thing I want to talk about before I let you go for the day is how, or what do we see happening in this? How do we know? Okay. Well, we look at data from a lot of different variables. Okay. NOAA, the National Oceanic and Atmospheric Administration, they work with scientists around the world. NASA, NASA, the Space Administration, right? And then NOAA, NASA, EPA, they're all working together, collecting data, trying to figure out what the story is. So we are looking at solar input, wind patterns, cloud cover, the temperature. Well, that would be the Earth's temperature, right? But the troposphere, what's happening in this level of our atmosphere, sea surface temp. So we know oceans absorb water. We just talked, or absorb heat. We just talked about that. How is it absorbing more heat? Is it not absorbing much heat? What's happening there? The amount of ice cover. Do we have periods of ice cover growth? Yes. I mean, when we get to wintertime, you're going to see ice grow. However, we're seeing less growth and more loss over the years. Okay. Also, again, rise in sea level. And we're going to talk about a lot of these individuals. So when we look at this, we put all this data into a computer model, right? Computer models are going to be something that can take a lot of different variables, put them together. So here's some examples. You guys have seen these maps around the world. You've seen globe pictures, right? Looking at how the temperature changes, what are the variables that are happening. So you can see how computers can take this information and compare one-on-one, right? We're also comparing not only those variables, sorry, now I've lost them all, the many variables, but also what do we know has happened? What's happening now? How does it compare what's happening in the past? What are those things that are working together? So this is what's happening right now in climate. And we're going to compare what's happening now to what we've seen in the past. So I hope everybody feels like on a good start with this, and go ahead and take those quiz questions, and we'll talk to you soon.